Good morning, dear 10th class students. We already discussed about the concave mirror and convex mirror. Today onwards, we are just starting our convex lens. And first of all, we will write about the convex lens. It is rules for the ray diagrams. Rules for the ray diagram. Okay. So first, we have to write that rules for convex lens. Okay. Rules for convex lens. So yesterday we already discussed about the what is the convex lens. It means the nature of this convex lens is converging nature, okay, and the nature of the the nature of the concave lens is diverging nature. And we already studied what are the main parts in the lenses. Like that, we already studied about that. One, if there is a lens, then if this middle point is known as optical center. A ray passing through the optical center is known as principal axis. Okay, and if the light rays are just parallel to principal axis, and after refraction, if they are meeting to each other or passing through the point, that is known as the principal focus of a convex lens. Okay, so we will study. We already studied these things, and now we are studying only about the rules. It is how to ray diagrams will be the form, and after that, what are the main cases what are the main conditions through which the main cases will be the formed. Okay. So look, first our rule is Okay, stop writing. Look first here. Rules for convex lens. It means how the ray diagrams will be the formed during the convex lens, and the image will be the formed on the basis of that. So a ray of light which is parallel to the principal axis. So this is the principal axis for us. Okay, which is passing through the optical center of the lens. This is the convex lens. Okay, we are studying here about the convex lens. After that, we will study about the concave lens. So a ray of light which is just parallel to the principal axis passing through the lens form the principal focus, okay, forming a principal focus here, and is the point on principal axis formed by refraction. So a ray of light which is parallel to the principal axis after passing through the lens form a principal focus which is a point on principal axis, which is a point on the principal axis. So you have to be notified that this is the parallel line to the principal axis, and after passing through this lens they are forming the principal focus here. Okay, so a line which is a parallel to the principal axis after refractions they will make and form the principal focus. Now second one is a ray of light which is passing through optical center get refracted without any deviations. Okay, so a ray of light which is directly coming to the center, optical center, so they are just refracted but without any deviation. There is no changing in the bending of light. And a ray of light which passes through a principal focus of a lens after refraction will be parallel to the principal axis. It means a ray of light which is coming directly to the focus after refraction, it will be the parallel to the principal axis. So these three rules is for our convex lens. First we have to write out. Look one diagram for this. What are the main differences between the nature and behavior of lens and the mirror? Okay, so look here. So this is the parallel line, principal axis same here. Here it is a hole for the mirror, but here it means this on this place. This is the midpoint of this. The reflecting the transparent substance is known as optical center. So we are just telling here that in the lens there is a two focus, okay, mirror also there is, but in mirror also like a real and virtual focus, and for this convex lens there is a one real focus will be made here. Okay, so you have to know if there is actually a ray passing through the principal focus, or I will say it in other words, if rays are meeting at a particular place actually, it means actually and appears. These both are different conditions. Okay, appears to meeting at a point and actually meeting at a point, both are different. So where appears to meeting at a point, they are known as a virtual things. They are known as a virtual things. And if light are meeting at a point or intersecting actually, so they are forming the real focus. So in this convex lens, the real focus is it means making here, and this is the virtual focus for that. And the one center of the sphere, okay, that known as the center of the curvature. Instead of here, it is twice the focal length. Okay, twice the focal length means a length which is made between the optical center to focus. Okay, so same thing we already studied in the mirror. A distance of between the center of curvature to pole is twice the focal length. So that is the radius also. So this C to F distance is the focal length, and this one is will be the double of the length. And may you have to tell this one is the radius for that. So like that, here it is a focal length, and this one is also twice the focal length distance. Okay, so we have to see, and what are the changes we just clearing here, that 2F is the position like in the mirror of like C position, like center of curvature. Okay, so you have to notify that. Draw it fast. Okay, stop writing. First, you have to understand here. Okay. Listen. These are the formation of images by convex lens. So, position of object. This is the position of image, size of image, and nature of image. Okay. So, everything is a different question for us. So, object in between C and F dash. Okay. I already introduced the F dash. What is F dash? Okay. And 2F dash. F and 2F. So this is the position for f dash. This is the 2f dash, f and 2f. So look, this is the first ray diagram for us. The formation of image here, it is a enlarged, okay, and same side of the object. So this is the same side of the object because we are already keeping this object in this way, and always either maybe the mirror or maybe the lens. We always keeping the object on the principal axis and this side of the lens or mirror. So when we are keeping inside the focus, okay, in between, it means in between the C and F. So this is the C and this is the F. So when we are keeping the object here, okay, this is the size AB. We are representing here. So the formation of image is the same side of the object and with virtual and erect. Why virtual and erect? Because the formation of image is in this side, okay, then virtual image, virtual and erect. And if the image is formed like this, in this way, is this side, like in this side already formation, so they are known as the real and inverted, okay. So this enlarged, this is highly enlarged image, you can see just behind of the object. Then virtual and erect here forming. Then object and focus. Okay, if we are keeping the object at focus, then formation of the image at the infinity. Okay, and you can see easily with the help of this ray diagram. And highly enlarged, always when the image is formed at the infinity, the nature of or the size of the image will be the highly enlarged. And real and inverted, object is in between the f dash and 2f dash, okay. So this is the f dash and 2f dash. We are keeping objects here. Then formation of image is just as beyond the 2f. So this is the 2f and this is the beyond of the 2f. So a dash and b dash, formation of image here. Then at 2f, okay, if we are keeping the object at here 2f, okay, then size of the image will be the same size of the object. So these are known as the a dash, b dash here, and if we are keeping object at 2f dash, then formation of the image at 2f. Same size, real and inverted. Beyond 2f dash, okay, it means beyond 2f dash we are keeping the object, then the formation of image in between the 2f and f anywhere, okay. Then diminished image, okay, less than image will be formed here, not too much long here. So it means the size of the image will be less than the size of the object here. Then at infinity, at f, okay, when the infinity rays are coming, then at f the image will be the form, and they are highly diminished. It means very diminished. So you already seen this type of way, but what are the differences here? Only instead of center of curvature, we are taking here 2f, which is the twice the focal length, okay, which is the twice of the focal length. So first of all, you have to draw this diagram. Uses of convex lens to correct hypermetropia, defect vision, Okay, so what are the uses? You can look to correct hypermetropia. Okay, so this is the defect of vision. Now this time not in your course, but briefly you have to understand that convex lens using to correct the defect vision, that means the hypermetropia, in which you can see easily the far away objects, but nearby objects you cannot see. In slide projector also, in microscope also, in magnifying glass also, by the palmist, okay, generally they are used by watchmakers to see the fine parts of the particular watch, okay, and in telescope also to make combination with other lenses, okay. Sometimes we need in the defect of vision to make different type of combinations, maybe sometime with the concave lens or with the convex lens. Now we are studying about the sign conventions of the lens. Okay, so you have to write down. So we already seen some main points, okay, for the sign convention of the mirror. So not more are too much different from that, okay. So all distance, first you have to write all distance measured from optical center in the direction of incident light Okay, look here, stop writing. So this is the sign convention for lenses. Like the distances upward. Okay, so all distances are measured from optical center, which is the midpoint of this refracting surfaces. So in the direction of incident light, distance will be the positive. This is the direction of incident light. Opposite direction of incident light, distance will be the negative. That's why object distance are just having the negative distance. It means the object distance always negative. Distance upward to principal axis positive and distance downward to principal axis negative. Next is length formula, that is 1 upon V minus 1 upon U is equal to 1 upon F. So here it is a different with the mirror formula. In the mirror formula we already seen that 1 upon V plus 1 upon U is equal to 1 upon F, and showing a relationship between the object distance, image distance and focal length of a lens. Next is magnification for the lens. Okay, for the magnification you seen for the mirror, that is m is equal to minus v upon u is equal to h2 upon h1, and here it is m is equal to v upon u h2 upon h1. So h2 is the height of image, h1 is the height of object, v is equal to object distance, and v is equal to image distance, u is equal to object distance. And if m is a positive value having, then virtual is x, and m having a negative value, then real and inverted image. Okay. So you have to write down these things. After that we are starting the rules for the image formation for concave lens. Okay. Okay. So first you should see here. So these are the rules for image formation in concave lens. Okay. So first rule is, look here, stop writing everyone. A ray of light coming to focus. Okay, it is coming to focus. After passing through the lens will be the parallel to the principal axis. It means after passing through the lens, it will be the parallel to the principal axis. A ray of light which passing through optical center proceed to same path. Okay, so this is the same path along without any deviation. So there is a no deviation, just like a convex lens. It also happen in the concave lens. And a ray of light which is a parallel to the principal axis after passing through appears to be coming from focus. So after passing it will be coming from the focus. Okay, so these are the rules. Okay, and two cases, okay, about this we will study in next online classes. Okay, thank you.